Welcome everyone. So last class we binomial distribution complete korisilo. So today we will start with Poisson distribution. So Poisson distribution jodi সহজ ভাষাত ক'ব লগা হয় is a distribution that is built upon binomial distribution. So binomial distribution at ami duta restriction dhori লৈছিলো. If you remember the concept of binomial distribution ami dhori লৈছিলো যে every trial right trial at duta outcome thakibo pare either success or failure, right? And next is that a trial 2 is finite number of times repeat kora goise, right? Because n is finite boli tat ami assume kori loisilo. So he concept tur uporot base koriye jodi ami eta ko je this infinite, your n is infinite, right? The number of trials is repeated jiman bar he particular Bernoulli trial to kiman bar repeat kora goise binomial khetrot n eta finite number loa goisile, right? In most of our example ami 10 12 or max 20 dekhisu, but atke besiu hobo pare, but it is a limited number of times. Jodi etia enukwa hoy je this number is very huge, tak mane bahut bar repeat kora goise, and we can consider it as an infinite number, right? Or countably infinite ba bahut dangor value eta. That is one condition. Next condition, the binomial distribution is the probability of p, right? P is the probability of success. P is the probability of success. So binomial distribution tumi dekhiba je suppose coin tossor experiment tot ami ki dhori jodi fair coin hoy p 0.5 hoy, q tumar 0.5 hobo, means half hobo duita, right? Probability of success and failure homan hobo, but approximately value usora usore thake. That means the probability of success is a big number, eta dangor value thake, right? But jodi enukwa hoy the probability of success is very negligible, right? So tetia ki hobo? So the concept of binomial distribution arises under two assumptions. The binomial distribution of binomial distribution or jodi n tends to infinity hoy jay, the number of trials is very huge, or probability of success jodi khub kom hoy jay, is negligible hoy jay, then at a variable, random variable jodi binomial distribution follow kori asile, it start following Poisson distribution, right? He Poisson distribution ole convert hoy jabo. So that is Poisson distribution. By the way, etia tumalokor syllabus or notun syllabus model tumalokor Poisson distribution or derivation mane ei keneke binomial distribution opora initially lagisile, how we can achieve Poisson distribution from binomial distribution, but etia hetu tumalokor drop kori dia hoise. So I will directly go to the definition, right? So definition: a random variable, precisely a discrete random variable, capital X is said to follow Poisson distribution if the probability mass function is given by probability of x equal to small x is e to the power minus lambda to the power that's x by x factorial. Yate property ki hoise that this x should goes from 0 1 to up to infinity loke jabo pare, right? And then this lambda is a positive quantity, lambda negative nohoy. So these are the condition of Poisson distribution, right? So it's a bit different from your binomial distribution. Binomial distribution tumar janake ncx p to the power x q to the power ncx he format tot nohoy, but it is quite easy for calculation in your Poisson distribution. So after that, let's go to your mean and variance. Janake ami binomial distribution of mean and variance calculate korisilo, thik tenore ami etia Poisson distribution of mean and variance calculate korim. So let's go to next page. This mean and variance of Poisson distribution. So achata agot in this there is something that I would like to add here. Je yet lambda is the parameter, right? So binomial distribution of duta parameter asalse n and p, right? Yate just etai parameter, that is lambda. Lambda is the parameter. Or jodi random variable to Poisson follow kore with parameter lambda, tak shortcut or denote koribo karone ami use koru p lambda. That is how it is denoted. Capital P for Poisson distribution, lambda is the parameter, right? So tumak jodi enake likha thake x 5 enuka kori jodi dia ase tar ortho tumi buji paba je lambda value is 5, lambda equal to 5 or Poisson distribution, and loga loga tar probability mass function to be identify koribo pariba je e to the power minus 5 to the power x by x factorial, right? So Poisson a lambda value to janar loga loga entire Poisson distribution to ami identify koribo paro. So we will go to mean and variance of Poisson distribution. Let capital X follows Poisson lambda. Now mean is equal to expectation of x, which is equal to summation x px is equal to, it a Poisson distribution of x can goes from 0 up to infinity, right? So 0 to infinity x, and our er third ki bohibo probability mass function. So it is e to the power minus lambda to the power x by x factorial. So last time binomial distribution khetra to factorial cancel out koribo parisilo ami, so factorial cancel out hoisilo. So the concept here also is somewhat similar, je ami factorial to cancel out korim. Thik tenadare etia yat sabo loga hole tomar e to the power minus lambda term tot kono dhoroner x or logot relation nai, that means ei summation or logot tar kono relation nai. So tak ami bahirot likhibo paro. So we will write e to the power minus lambda to bahirot, x goes from 0 to infinity, x lambda to the power x into x minus 1 factorial, right? So this is equal to e to the power minus lambda, aru eta lambda ami bahirot loi ahilo, okay? So summation ax cancel out hoi gol, tolot thakile x minus 1 factorial, eta lambda bahirot ahi golo, so it is lambda to the power x minus 1, okay? So etia this is a summation to ase. Initially it was starting from 0 up to infinity, right? So initially x or 0 bohale 0 factorial asile, which is 1, fine. But etia jodi ami 0 para start koru, so it will be 0 minus 1, that is minus 1 factorial. Eta minus 1 factorial possible nohoy, he karone ami 0 place koribo noaru. So he restriction or karone ami etia x ko para start koribo lagibo 1 or para start koribo lagibo. So when we put x equal to 1 minus 1 0 factorial, so it is possible. So let's go to the next line etia ki hobo je it is e to the power minus lambda into lambda etia ami ei summation to expand korim so when you place x equal to 1 bohale ki hobo eitu side x equal to 1 bohar lage lage etu 0 factorial to lambda to the power 0 so anything to the power 0 is 1 and 0 factorial is also 1 so you will get basically tomalage lambda to the power 0 by 0 factorial paba next lambda to the power 1 by 1 factorial paba next lambda to the power 2 by 2 factorial paba and anake goi thakibo since infinity so it is not closed right so next step what we can write e to the power minus lambda into lambda so this is nothing but 1 lambda square by 2 factorial lambda cube by 3 factorial and so on it a summation to this series is nothing but expansion of e to the power x is written as 1 plus x square by 2 factorial x cube by 3 factorial and so on so e to the power x ok enake likhibo parile eitu value ki hobo yate x or thait just lambda ase right so this is nothing but e to the power minus lambda into e to the power lambda the e to the power minus lambda cancel out whole so we got lambda right it a lambda car value hoy it is the value of expectation of x so let's mark this number 1 so my expectation of x is so we got expectation of x is lambda is the mean right so the mean of Poisson distribution is the parameter itself right there itself the parameter to g heitue mean so next we will go to variance right so now variance of x ki hoy expectation of x square minus expectation of x whole square এটা জেনেকে বাইনোমিয়াল ডিস্ট্রিবিউশনটো এক্সপেক্টেশন অফ x স্কয়ার উলাবৰ কাৰণে আমি কি কৰিছিলো এটো এডজাস্টমেন্ট কৰিছিলো সো নাও ইয়াতো আমি হে একেটাই কৰিম right so expectation of x square is nothing but expectation of x into x minus 1 plus x right so which can be written as expectation of x into x minus 1 plus expectation of x so now eti ami kihor value ulaw lage expectation of x into x minus 1 right this is equal to summation x into x minus 1 px right so this is equal to x etia kor pora jabo 0 to infinity right and then x into x minus 1 px ki asile e to the power minus lambda to the power x by x factorial so e to the power lambda right last time ami lambda ulaisilo ebar ami duta lambda ulai lohim eta lambda ulaisilo ebar duta lambda ulai lohim summation x goes from 0 to infinity and then tomar x into x minus 1 yar cancel out hole you will get x minus 2 factorial and uporot thakibo lambda x minus 2 why x minus 2 because duta ami bahirot loi goisu so this is equal to e to the power minus lambda into lambda square etu x or value etia yate 0 bohabo nwara tumi yate we cannot place 0 why because 0 bohala itu minus hoi jabo so we will have to start from 2 so that 2 bohua logale iti 0 factorial our objective is always the prothom value to 0 hobo lage right 0 factorial hobo lage yat value to enake select koribo lage jate yat 0 factorial ahe so this tumi jodi expand kora you will again get 1 lambda square by 2 factorial, sorry, lambda cube by 3 factorial, and so on. So which is nothing but lambda square into e to the power lambda. So it is lambda square. So আমি কি পালো, expectation of x into x minus 1 is lambda square. But আমাক লাগিছিলে কি variance of x ওলাব লাগিছিলে, right? So তাৰ কাৰণে প্ৰথমতে কি কৰিব লাগিব, so আমি this is expectation of x into lambda square পালো, expectation of x is lambda, so lambda square by 2 পালো আমি expectation of x square. So এটা variance কি হ'ব, প্ৰথম টাৰ্মটো হ'ল lambda square by 2 minus expectation of x is lambda, so lambda square. So lambda square cancel out whole, a2 and a2 cancel out whole, we are left with only lambda. So that means আমি কি পালো, therefore the variance of x is also lambda. So আমি কি পাম যে Poisson distributionৰ কাৰণে, so the property is for Poisson distribution mean equal to variance equal to the parameter lambda, right? So this is a very interesting property and এইটোৰ ওপৰত তোমাৰ বেস কৰি বহুত calculations and etc and questions আহে, short questions আহে, multiple choice আহে. So তোমাক ধৰিলো mean or value দিয়া আছে and Poisson value, standard deviation of value দিয়া আছে, and then you have to define whether it is a Poisson distribution or not. ঠিক তেনেদৰে তোমাক যদি mean or value দিয়া থাকে, you have to predict the value of standard deviation. So here are a lot of possibilities আছে based on this single property, right? The mean and variance equal হয়, right? So next we will discuss the recurrence relation for the probability of Poisson distribution. So recurrence relation mean whole that তুমি যদি prior আগৰ stepৰ probability to জানা, that means x equal to 0 জানা, তুমি x equal to 1 ওলাব পাৰিবা, 1 জানিলে 2 ওলাব পাৰা, and so on, right? So recurrence relation for the probability of Poisson distribution. So if x follows Poisson with parameter lambda, then probability of x is equal to e to the power minus lambda to the power x by x factorial. The probability of x plus 1 will be e to the power minus lambda to the power x plus 1. x or thai jodi ami x plus 1 place kor, this will be x plus 1 factorial. Now probability of x plus 1 divided by probability of x will give you e to the power minus lambda to the power x plus 1 by x plus 1 factorial, and then e to the power lambda to the power x by x factorial, right? So e to the power lambda cancel out হৈ যাব, so তোমাৰ হাতত বাকি থাকিব this lambda x plus 1 divided by x plus 1 factorial. এতিয়া এইটো যদি product হিচাপে লিখিব লাগে, x factorial to ওপৰলৈ যাব, x factorial and lambda to the power x separate কে থাকিব. Now we can write here lambda to tumi likhibo para lambda into lambda to the power x, and this is x plus 1 and tar next x factorial hobo, right? So this is x factorial, this is lambda to the power x. So if I cancel out, I will get lambda by x plus 1. It is to kihor value. This is the value of probability of x plus 1 by probability of x. So next step ami probability of x plus 1 likhibo paru as lambda by x plus 1 into probability of x, right? So this is the recurrence relation of your Poisson distribution of probability bilak, right? So let's do few examples of Poisson distribution, then we are done with Poisson distribution. Poisson distribution tomorrow iman nai, so before example let's do some applications, but Poisson distribution or real life or code examples ki ase, right? Examples of Poisson distribution. Examples of Poisson distribution. So number 1 is number of misprints or printing mistakes in a misprints means your printing mistakes on a page of a book, right? On a page of a book. Now if the book is good, jodi ekhon bhal publication opora kitab khon print hoi aise tete prottek tu page ot kiman ta print ase, that is very rare, right? So basically eta kotha monot rakhiba je Poisson distribution, your Poisson distribution is the distribution of rare events. Rare events অর্থটো কি হল যে খুব কম কে হয়, রাইট? সো ইয়াতে তুমি ফেইলার হোৱা probability, এটা অলরেডি তুমি যেটো কনসেপ্ট আছিল অ্যাজাম্পশন আছিল, অ্যাজাম্পশনটোত আমি কি ধৰি লৈছিলো যে probability of success is very low. Probability of success, that is p tends to যদি 0 হয়, q tends to 1 হ'ব লাগিব, right? So you will certainly be failed, right? The failure হোৱা probability তোমাৰ বেছি আছে. So enuka event eta jot tume fail hua chance besi ase, that means it is very rare, right? Je hetu hua khub kom honkha thakibo pare. So thik tenare etia tumar yate number of misprints hodai tumar konuba khonot maximum page ekhon kitabot tumi paba je tat kono dhonor misprint hua nai. Tumi ekhon dukhon kitab page paba jot dhori loi eta duta tumar misprint hoise, right? So as you keep on increasing the number of misprint, the 10 printing mistake ekhon page ote hua chance khub rare, right? So that is the concept of Poisson distribution, je tumi yate success howa probability kom, is a distribution of rare event, je jitu bostu rarely hoy, khub সাধাৰণতে নহয়, তেনুকা ধৰণৰ ইভেন্ট বিলাকক দেখাবৰ কাৰণে আমি Poisson distribution use কৰো. So number 2, suppose number of accidents per hour in a traffic point, right? So eta traffic point jodi ami bohi observe kori thaku ba traffic police jone jodi observe kori thake prottek ghantate kimanta tumar tat accident hoise, maximum time it will be 0, right? Prottek ghantate jodi tumi number to calculate kori thaka maximum time 0 accident hoise, ketia ba hoyto eta hobo pare, khub rare case ot duta hobo pare, but tatke beshi ek ghantat accident howa chance tatkeu kom, right? So that is another example of your Poisson distribution. Number 3 is say number of deaths by suicide, that is also a rare event. So these are examples of Poisson distribution, right? So next we will do some exercise. exercise number 1 দিয়া আছে যে x follows Poisson distribution, right? Poisson distribution with parameter lambda and probability of x equal to 0 is equal to probability of x equal to 1, right? And these both are equal to a. Then find a কি হয়, right? So আমি ধৰি লৈছিলো যে Poisson distribution ফলো কৰে with parameter lambda. By the way, question to এইটো দিয়া নাথাকিব পাৰে, এনেকৈ দিয়া থাকিব যে x follows Poisson distribution, right? So আমি ইয়াত সলিউশনত তুমি লিখি ল'ব লাগিব যদি দিয়া নাথাকে যে let x follow Poisson distribution with parameter lambda. Then probability of x equal to 0 কি হ'ব? e to the power minus lambda, lambda to the power x হ'ব লাগে, so x 0 হ'ব and 0 factorial. Something to the power 0 is 1, 0 factorial is 1, so you will get e to the power minus lambda. So probability of x equal to 1 হলে কি হ'ব? It will be e to the power minus lambda, lambda to the power 1 by 1 factorial, right? So this is 1 factorial is 1, lambda to the power 1 is 1, so lambda e to the power minus lambda, right? So ইয়াত তোমাৰ যদি এই দুটা equal to 1 হয়, that means you will get e to the power minus lambda is equal to lambda e to the power minus lambda, because probability of x equal to 0, since probability of x equal to 0 is equal to probability of x equal to 1, therefore e to the power minus lambda or lambda to the power e are same. So this implies a to cancel out hola, you got lambda is equal to 1, right? Lambda equal to 1. It a question dia ase now probability of x equal to 0 is equal to a boli dia ase, right? So this implies probability of x equal to 0 ki hoy e to the power minus lambda hoy is equal to a hoy. The lambda ami kiman palu 1 palu, so it is e to the power minus 1 is a, right? So a bele eku nohoy, a is nothing but 1 by e. 1 by e libo pare ba e to the power minus 1 or eta particular value ase, the same thing. So tumi ji dhorone nilikha kyo, this is the result, right? So that's the solution. Let's go to the next question, which gives a Poisson distribution. So the question is exercise number 2. A random variable x is such that probability of x equal to 1 is equal to probability of x equal to 2 times of probability of x equal to 2, right? If x follows Poisson distribution, then find number 1 probability of x equal to 0 kiman hoy, and number 2 is probability of x greater than equal to 0 kiman hoy. Okay, so you have to solve this. So solution not ki dia ase the probability of x equal to 1 and 2 times of probability of x equal to 2 ase, right? So we will start with that concept. So ami dhorisu je let x follows Poisson lambda, right? Poisson lambda hole etia dia ase the probability of x equal to 1 ki hobo, it will be e to the power minus lambda, lambda to the power 1 by 1 factorial, so lambda e to the power minus lambda, right? And probability of x equal to 2 hole ki hobo, it will be e to the power minus lambda, lambda square by 2 factorial. It was a now probability of x equal to 1 is equal to 2 times of probability of x equal to 2. So this implies ki hobo e lambda e to the power minus lambda is equal to 2 times of e to the power minus lambda square by 2 factorial. Eta 2 factorial 2a hoy. So this cancel out hoy gol. E to the power minus e to the power minus lambda cancel out hoy gol. So you got lambda is equal to lambda square. Right? Eta lambda cancel out hole we will get lambda is equal to 1. Right? So that is lambda equal to 1. So ami palu je lambda is equal to 1. So that means lambda power loga laga the entire distribution is, therefore x follows Poisson 1. Eti ami ulabo laga probability of x equal to 0 or x greater than 0, right? So number 1, probability of x equal to 0. Eta probability of x equal to 0 ki hobo? It is nothing but e to the power minus lambda, right? Lambda mane ki minus 1. And then lambda to the power 0. So 1 to the power 0 and 0 factorial. So we get e to the power minus 1. The value for which is 0.368, e to the power minus 1 of value, right? That's you got. The next question to a2 tomar calculator use koribo para, but there is a table use koribo lage. Table use korile tumi value to pawa. So then, and most of the time question not a2 karone tumalake chinta koribo nalage. Question not kahot tumar dia thake a value to e to the power anything that will be used in your example. Je jitu solution kori asa tar jitu use hobo heitu tumar most of the time dia thake question not. And now we need probability of x greater than equal to 0. So jodi x of value 0 1 2 3 4 enake go up to infinity thake, amak lage greater than equal to 0, right? Greater than equal to 0. So greater than equal to 0 means gute gita, right? Everything 0 ke dangor, right? 0 saman ba 0 ke dangor. So everything eta gute khini include hole ki hobo? Everything or probability, the entire sample space probability hoday 1 hobo lage, right? So that is etia jodi eitu greater than nathakil hoy je third jodi suppose tumak ulabose probability of x greater than 0, strictly greater than, tetia ki hobo 0 bahire baki khini, right? So gute khini probability, the entire thing probability is 1. So 0 to tabra bad dibo lage. So it will be 1 minus probability of x equal to 0. That is 1 minus 0.368, right? Heitu value hobo probability of x greater than 0. Equal to dia say, that means 0 include hoise, that means this 0.36 a2 that include hoise, that's why this is the solution, right? So let's find out that this is our last question, last exercise of Poisson distribution. Okay, so next question. Suppose question is exercise number, so exercise, suppose 300 misprints are distributed randomly throughout a book of 500 pages. Find the probability that given page contains 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × 1 × number 1 exactly 2 misprints, and number 2 2 or more misprints. Right, so etu hol question. So here solution to koribo loga hole, if you go to the solution of this problem, yata koise je 300 misprint ase, right? So total number of misprint is 300 and that page ase 500, right? So on an average per page 500 khonot jodi 300 ta misprint tumi bhogai dibo lage, that is the average, right? So this 3/5 is your average. It a Poisson distribution of jodi number of misprints. So let's structure this formula. Let capital X denote the number of misprints in a page, right? Eta page or thoka misprinter suppose capital X e denote korise. Now X bar is number of misprints, average misprints is 300 by 500, which is 3/5, right? So X bar, X bar আমি Poisson distribution যদি follow করে, obviously না আমি কৈছো যে example আছে number of misprints follows Poisson distribution, right? So ইয়াতে কৈছে যে suppose 300 misprints are distributed randomly through a book of 500 pages, find the probability that given. So exactly 2 means X equal to 2 লাগে আৰু 2 or more means greater than equal to 2 লাগে, right? So therefore X follows Poisson distribution with parameter 3/5 because it's a lambda, right? Mean mane lambda, right? Now we are to calculate probability X equal to 2 and number 2 probability of X greater than equal to 2. So number 1 probability of X equal to 2 hobo is just tar probability mass function of bohai dibo lage. So e to the power minus lambda, so lambda is 3/5, lambda to the power, so 3/5 to the power X means 2 and 2 factorial. Okay, so that will give you the probability of X equal to 2. Etia amok probability of X greater than equal to 2 lage. So if the values are 0, 1, 2, 3 up to infinity, right? So we are interested in greater than equal to 2, that means 2 pora arambho kori entire line. Ite infinity ase to ami hekhot ki ase heitu value to ami obviously ulabo nuaru, but we know the entire line to probability is 1. So আমি কি কৰিম যে 1 of probability of X equal to 0 or X equal to 1 minus কৰিম ইয়াত. So it will give, this is nothing but 1 minus probability of X equal to 0 plus probability of X equal to 1, right? This is the formula. So this is nothing but 1 minus probability of X equal to 0 in case of Poisson distribution, lambda value j no kyo probability of X equal to 0 hodai e to the power minus lambda hoy, because lambda to the power 0 and 0 factorial ei dutai 1 1 hoy naikia hoy jay, right? And probability of X equal to 1 ki hobo is always e to the power minus lambda, lambda to the power 1 by 1 factorial. So 1 factorial to nilikhila hoy, so it is lambda e to the power minus lambda. So yat ki hobo e to the power minus 3/5, which is the lambda, plus lambda means 3/5 into e to the power minus 3/5. So if you solve this, you will get the value. So try to find it down. This should be 0.099 and this should be 0.122. প্লিজ ভেৰিফাই এই দুটা ৰিজাল্ট ওলাই নে নোলায় right so that is your numericals on Poisson distribution so today we discussed about Poisson distribution the Poisson distribution কি হয় how Poisson distribution is arrived যে তালৈকে আমি কেনেকৈ আহিব পাৰো and then last আমি next Poisson distribution আমি mean and variance calculate কৰিলো mean and variance calculate কৰাৰ পিছত আমি দেখিলো যে mean আৰু variance দুইটা সমান right mean and variance of Poisson distribution are equal and then আমি recurrence relation calculate কৰিলো this is the recurrence relation then these are the examples of Poisson distribution right examples the very rare case যদি তেতিয়া Poisson distribution apply কৰা হয় then we did some numericals on Poisson distribution okay so that's all for today in next class we will start with normal distribution is a continuous distribution and normal distribution are under comparatively binomial and Poisson ke normal distribution are basic concept basic numericals and completely different types of approach of problem solve kora which will be a bit more tough compare jodi kora binomial and Poisson ke normal distribution ot kaam kora olof beshi tan but it is comparatively easy ketiaba because you don't have to find out exact values so in next class we will discuss about normal distribution that's all for today see you in the next class